You are standing in a room full of strangers at a party, and someone asks you your earliest memory. You pause. You reach back. Maybe you find something, a birthday cake, a car ride, a dog, but nothing before the age of 3 or 4. Nothing. Just a wall of silence, where the first years of your life should be. And here is the strange part. You were awake for all of it. You were learning. You were feeling. You were there. So where did it go? This is one of the most quietly unsettling mysteries in all of human psychology. Researchers call it infantile amnesia. And the answer to why it happens is far stranger and far more revealing about who you are than you have ever been told. Start with what most people assume. Most people hear you can't remember being a baby and assume the brain simply wasn't recording, like a camera with no memory card. The events happened, the images formed, but nothing saved. That assumption feels right. It feels logical. It is also wrong. Your brain was recording. Constantly. Obsessively, even. In the first 2 years of life, the human brain forms roughly 1 million new neural connections every single second. 1 million. Per second. Neuroscientist Lisa Elliott, who spent decades mapping early brain development, described the infant brain not as an empty vessel, but as an explosion. A fireworks show happening in every direction at once, with no pause button and no off switch. Your brain was not absent during those early years. It was more active, more plastic, more hungry for input than it will ever be again for the rest of your life. So the problem is not that nothing was recorded. The problem is something far more interesting. The problem is that the recordings can't be played back. Here is why. Memory is not one single system. This is the part that most people get wrong when they think about the brain. There is no single vault where memories are stored, no filing cabinet, no library. Instead, your brain runs multiple memory systems in parallel, and they are fundamentally different from each other. One system handles procedural memory, how to walk, how to grip a spoon, how to balance on 2 feet. This system develops early. This is why you don't forget how to ride a bike. It's wired into your body. Another system handles what researchers call episodic memory, the movie-like, narrative memories of specific events. Tuesday afternoon. The smell of rain. The face of a person you loved. The story of your own life. This is the system that goes silent in infancy. And the reason it goes silent has everything to do with a small, curved structure buried deep inside your brain called the hippocampus. The hippocampus is the brain's memory consolidator. It takes raw experience and encodes it into long-term narrative memory. Think of it as the editor who takes hours of raw footage and turns it into a story you can revisit later. Without the hippocampus doing its job, you can experience things, feel things, react to things, but you cannot store them as retrievable stories. And in infancy, your hippocampus is not yet online. Not fully. It is still being built. The neurons are still migrating into position. The infrastructure for long-term episodic memory is still under construction. Psychologist Alison Gopnik, one of the leading researchers in infant cognition, has argued that this is not a design flaw. It is a feature. The infant brain, she suggests, is optimized not for remembering but for learning. It is a lantern, not a spotlight. It takes everything in, broadly, without hierarchy, without the filtering system that adult memory requires. Adult memory is selective. It prioritizes. Infant memory cannot afford to prioritize because it doesn't yet know what matters. So your brain in infancy was doing something extraordinary. It was absorbing the entire world simultaneously. Language, faces, physics, emotions, cause and effect, the feeling of being held, the sound of a voice that meant safety, all of it pouring in, all of it shaping the architecture of who you would become. But because the hippocampus was still developing, none of it was filed into the episodic drawer. None of it was tagged with a date and a face and a smell into the story of your life. There is another layer to this, and this layer is the one that changes how you see yourself. Psychologist Catherine Nelson spent years studying how children develop what she called autobiographical memory, the continuous narrative sense of being a self with a past and a future. What she found was striking. Children don't just need a developed hippocampus to remember. They need language. More specifically, they need a self-story. The ability to remember personal events in a retrievable, narrative way appears to be deeply tied to the ability to construct a verbal narrative about your own experience. Think about what that means. You need words to hold memories, not just to describe them later, but to encode them in the first place. Before you had language, before you had the internal narrator that now runs constantly in your head, you could not structure experience into the kind of story that memory requires. Experience was happening to you, but there was no you yet in the narrative sense. No character, no protagonist. Just sensation, emotion, and perception flooding in from every direction. When did language arrive? When did that internal narrator begin to take shape? Around age 2 to 3, which is, not coincidentally, exactly when most people's earliest retrievable memories begin. But there is still one more piece, and this one is darker. Researcher Paul Franklin at the Hospital for Sick Children in Toronto studied infantile amnesia from a neurological angle, and what his team discovered adds a disturbing twist to the story. The hippocampus doesn't just fail to encode new memories in infancy, it actively disrupts old ones. In early childhood, a process called neurogenesis is running at full speed in the hippocampus. New neurons are being born constantly, flooding into existing memory circuits. And those new neurons, far from adding to the memory, appear to overwrite it. They rewire the circuits that stored earlier experiences, replacing old encoding with new, blank cells ready for new input. Franklin's research, conducted in both animal models and later supported in human studies, suggested that the very process that makes the infant brain so extraordinary at learning its explosive growth is the same process that erases whatever came before. Your brain, in other words, ate your early memories to make room for more learning. It sacrificed your past in order to build your future. And now consider what survived. You don't remember the first time you heard your mother's voice, but something in you responded to voices that sounded like hers for years afterward. You don't remember learning to trust or distrust, but those early experiences, the attunement, the warmth, the absence of it, shaped your attachment style, your nervous system's baseline, your default relationship with other human beings. The researchers Mary Ainsworth and John Bowlby spent their careers mapping exactly how those early, unremembered experiences leave permanent fingerprints on behavior, on anxiety, on the way a person navigates closeness and distance for the rest of their life. You didn't remember any of it, but your body did. Your nervous system filed everything it needed into the procedural drawers, the emotional body memory drawers, the threat response drawers. It kept the survival data and released the story. So here is what you actually are. You are a person whose earliest education, whose most formative classroom, left no episodic trace. The version of you that learned the most fundamental truths about the world, about safety, about love, about what to expect from other people, is a version you will never meet. You cannot interview them. You cannot review the footage. You can only see their influence in everything you feel and do and fear without knowing why. The scientist who asks why you can't remember being a baby is really asking a question about identity, about what makes a self, about the relationship between memory and personhood. If you were there for every moment of those first years, if you felt joy and terror and hunger and warmth, but none of it is accessible to your conscious mind today, were those experiences yours? Are you the same person who lived them? Most philosophers and neuroscientists would say yes, memory is not the self. The self is something more continuous than the stories it can retrieve. The patterns laid down in those early years are still operating. The version of you that cannot be remembered is still, in every meaningful way, running the show. Tonight, if you are lucky, you will sleep next to someone you trust, or reach for a comfort you don't quite understand, or feel a nameless ease in a familiar smell. You won't know where that ease came from. You won't remember the moment it was written into you. But it was there, you were there. And the part of your brain that mattered most made sure you would carry it forward, even after it erased every trace of where it came from.